Hi guys, so here is the second little set of notes I'm going to try to get while I'm still here today. So this one's on work and power. So the first thing we have here is if you are going to do work, okay, you have to apply a force. A force, if you remember, is a push or a pull on an object. So when you have work being done, the motion of the object that is moving has to be the same direction that you apply the force. So if the book moves upward like this lady is doing, then the force was upward. If I'm pulling the wagon and the wagon is going forward, I've got to be pulling forward. All right, so work and energy, okay? Energy transfer occurs when you do work. So you move the energy from one object to another. And the unit for work, once again, is just like energy, it is joules. Okay. All right. So work. Work is the transfer of energy that occurs when a force makes the object move. Okay. So remember, it has to be in the same direction as the force. So the force has to make the object move. All right. Now, when you get ready to calculate work, okay, you are going to say that you have the force moving at some distance. So here we have work equals force times distance. So if I wanted to put this in a triangle, I would put work up top, force, and distance at the bottom. And you can't see that, of course, because the lovely glare. All right, maybe you can see that. I'm going to write it over here again, just maybe getting out of the light might work. There's always flaws. I can now find a perfect system in this whole remote learning thing. I don't think that looks good either. So work we know is in joules, okay? Force is newtons, and distance was meters, okay? So hopefully maybe, let me see, maybe you can see that if you squint really big. I don't know what the best way is, guys. I'm trying all different ways. We'll see. Remember, if you have questions, you can always email and I'll try to help you. I can set up some sort of live or something. I might not be here. I'll be probably at home and you might have kids in the background, but I will definitely try to help you. So here's our first little example. It says Jessica applies a force of 2 newtons and moves the book 1.5 meters higher. How much work is done? All right, so if I want to do this, I would say work is equal to force times distance, okay? It says that she uses a 2 newtons force and she moves it 1.5 meters. So we're going to put that into our calculator, and most of you could probably do that math in your head, but 2 times 1.5, you're going to get 3, and since we're doing work, it is joules. Okay, so you're just plugging in those numbers. All right, so there it is, nice and pretty, where Ms. Griffin didn't write. Maybe you can actually see that better. Going 3. Okay? All right, now the second example. It says the 10 kilogram object accelerates at 5 meters per second squared and moves at 20 meters. How much work was done by this force? Okay? All right, so this time it has given me a mass and an acceleration, okay, and it says that we are moving 20 meters. So it didn't give me the force that I needed. So I've got to remember from the last unit that force was equal to mass times acceleration. So the first thing I have to do is say 10 kilograms times 5 meters per second squared. So you can do 10 times 5, I know. But 10 times 5 is 50, so that's 50 newtons, okay? All right, so now I'm going to plug that in to my distance of 20 meters, and I'm going to say 50 times 20, and I'm going to get 1,000 joules, okay? That would be the work that is done, okay? So what I'm going to do here is I'm going to erase all that, and it's going to pretty, I hope, come up here, and it's going to show us all of our steps nice and neat, not where Miss Griffin has written her scribble scrabble, okay? So once again, you had to do your force times to get your force first, you had to say mass times acceleration, and then you plug that into the work equation. Remember, sometimes there's 2 steps. All right, now power. Power is the rate at which work can be done, okay? So when I talk about power, okay, how much can I do in 1 second? So now we're talking about watts or kilowatts. Some of us, if we know about energy that's going to our house, we know power, they measure in kilowatts. All right, so 1 watt is equal to 1 joule per second. 1 joule per second. All right, so now we have this rate being done. So whenever you talk about rate, you know something's got to be divided. All right, so here is our equation, okay? Power is equal to work divided by time. So I'm going to make this into a triangle, and this time our triangle looks a little bit different because we actually have division, okay? So I have W up top, I have P, and I have T. Time is in seconds, okay? We just said that work was in joules and power was going to be in watts. That's a big W, okay? So that's joules, this is seconds, and this is watts. Don't get confused that W's work, okay? So once again, I would be making these sort of notations on my notes. You can be keeping your own paper notes for little handy things to help you as you solve. Okay? All right, now it says, how long will it take a runner to do 1,000 joules of work if his power is 125 watts? All right, so how long? This time we're looking for time. So that's why these triangles are so good. And if you guys remember at the beginning of our Unit 5 notebook that you guys all still have, because remember I collected the chemistry ones and I have those sitting right there on my shelf and I can't get back to you. But we did the little triangle sheet. A lot of these equations we had already put into the triangle, so that may be helpful for you. I'll try to get one uploaded to Google Classroom so you can look at and just make sure you are setting your triangles up correctly. But I really think if you would use the triangles and all of the solving that we have, it's really going to be helpful for you, okay? All right, so remember, we had power was work over time. So we have our work up here, we have power, and we have time. So I'm trying to solve for time. So time is going to be work over power, okay? All right, well, it tells me that I have 1,000 joules of work and that my power is 125 watts. So if I take my calculator and I say 1,000 divided by 125, I'm going to get 8. And this is time, so it's seconds, okay? 8 seconds. So there you have that. And there's the nice pretty without Miss Griffin's lovely writing everywhere, okay? So there you have that, 8 seconds. You divided. All right, now, this one says the book moves 4 meters with 5 newtons of force applied. It takes 2 seconds to move the book. Calculate the power. All right, so you all know that I like to work it out. I'll show you the nice pretty, but I like for you to see kind of a step-by-step writing. And so that's the way I do this in class, and that's why I have to do it that way when I'm trying to present it to you this way. All right, so we're going to say work over time, okay? Now, it says it moves 4 meters with 5 newtons of power. I don't have a work. I don't have anything in joules. So I have to remember that work was force times distance. So I need to say 4, well, let me go in the right order. 5 newtons times 4 meters. 4 times 5 is 20. So that's going to be 20 joules. And it says that it takes 2 seconds. So 20 divided by 2 is 10. And since this is power, it is watts. Okay? And I realize that that is right in that glare. All right, so let's see what it looks like when it's all typed in pretty. Let me get my lovely writing out of the way. So there's your reminder that you needed to do the work equation, okay? So we put in force times distance, and then we're going to divide that by time. So there's our 5 times 4 divided by 2. So that's 20 divided by 2, and we ended up with 10 watts. Okay, same thing that we worked through. Okay. All right, so those are our practice problems. Remember, if you have any questions, you can always email. I will try to address those as best I can. I can make a little tutorial video for you. I'm always open for you to maybe arrange some sort of Google Hangout that you and your classmates can do if you needed a little crash session tutorial. But you just have to ask. Hope you're doing okay. Miss you guys. Bye.